Swayam Prabha. Digital India. Educated India.
Okay. 1 second, sir. I will just start broadcast.
So this is a nice photo. Who has put this?
I only did, sir.
Oh, very nice. There's a muffler.
I searched for muffler acoustics course, and then I got that image, and then I used it, sir.
Right.
Sir, now we are live. It's a deferred live, like 30 seconds delay will be there.
Okay.
We are live, sir. We are live now. And then can you mute that audio icon in that YouTube, sir? Otherwise, echo will come, sir.
Oh, very nice. There's a muffler.
I searched for muffler acoustics course, and then
I mute this thing.
YouTube, you need to mute, sir. Otherwise, no echo will come, sir.
Okay.
Right, sir. Anyway, students will post their questions through chat mode only, sir. Right now, I'm going to post one question, sir. Just see whether you are able to mute.
Right.
Sir, I posted a question in the chat box, sir. Like I just greeted the students.
Yeah.
Are you able to see, sir?
In the YouTube chat box.
Yes, sir. YouTube chat box. Sir. Good evening, participants. The session will begin shortly. Kindly post your queries in the chat box.
Right.
Yes, sir. Right. Yeah, right now one is watching, sir. I don't know whether it is a TA or one person is watching now. And you can start the session with those two questions, sir. And then let's see how many students participate, sir. And accordingly, we will plan the session, sir. So I'm going to mute myself and then I'm going to disable my audio, sir. Sorry.
Yeah,
video.
I'll also close the video, but you know.
Sure, sir. In case of anything, you let me know, sir. I will be sitting here.
I'm just so officially started. I'll just wait for a few minutes.
Right, sir.
Yeah.
So after some time, you can start, sir, officially. But I'm going to mute myself, sir.
Yeah, okay.
Thank you, sir.
Murli,
Yes, sir.
well, I hope it's 5 minutes past 6, and there is not even a single participant.
Uh,
So,
Let
so
me.
I was sort of hoping the people would turn up.
Yes, sir. The student who posted the question offline, at least you can reply to that question, sir. And then we will wait for few more minutes, and then accordingly we will take a decision whether to end the session or not, sir.
Yeah, actually, only thing is that the question that he is okay, fine. Let me do something about it. So I have to fill up the form and write it and submit. Is it?
No need to fill up the form, sir. Two questions are there. No, sir. That you can discuss the question, sir. You can read the name of the student who posted the question, and then, or else shall I read the question, sir, for you so that you can
No, I
reply?
already have. Do you have any prescribed method to measure insertion loss of muffler using impedance tube?
Yeah.
And will it be worthwhile to provide reliable data for target setting? And transmission loss of muffler using statistical energy analysis. So, well, ठीक है मतलब I mean, I'm just hoping that the student turns up so that I can answer.
Yeah, we don't know, sir. Maybe he is unable to attend. That's why he posted the questions in the Google.
So, in case if that is the case, what should I do? Shall I just answer this question?
Yes,
fill
sir.
up the Google form.
No need to fill up the Google form. Orally, you need to answer, sir.
In this presentation.
Yes, sir. Is it possible to answer this particular question orally, sir?
Yeah, technically, yeah, it is possible. The second question, I'm not an expert in statistically. I can't answer that question.
Okay, sir. Second question you can ignore, sir. Second question you can ignore, sir.
Well, because I'm not an expert, and that is actually for that matter, these are experimental topics.
Okay, sir.
Which are not quite covered in this course. They are like very elaborate methods, and especially they were reserved for another advanced course that I'm planning.
Right, sir.
But I'll answer, since he asked, I'll answer whatever it is. And then with the understanding that more details will be provided in the due course.
Okay, sir. You can start, sir.
Yeah, so I'm just, I'll just wait for a while and then I'll start.
Definitely, sir. Fine, sir.
Well, good evening, everyone. I hope more students will join today. So I am your instructor Akhilesh for this course, NPTEL course. It started sometime in January, I believe, and the 12th week has just ended, the final week, and your exams are due. So there are 13 registered participants who will take up this exam, and so I wish them all the best to begin with. And there are only 4 participants who are watching presently. So I would encourage them to actually on YouTube, which is being broadcasted on YouTube. So I would encourage them to please kindly join the, join the YouTube, join the Zoom meeting, so that we can have a better interaction, and you can ask me questions if you have.
Excuse me, sir. Students won't join in Zoom, sir.
Okay.
They will simply watch the event in YouTube and post their queries in the chat box, sir.
In the chat box here, is it?
In YouTube chat box, sir.
Yeah, but I don't see any message apart from that other question, which I'll answer shortly. But so that's what I'm saying, that I would request the participants to kindly join the ask questions if they have any.
Yes, sir. They are yet to post, sir.
Yeah, we'll probably wait. If there are no questions after a few minutes, I'll take up this question and we'll see how we go.
Definitely, sir.
Okay, so we have a question. We have a question by Jaya Selham. As mostly we deal with plane wave behavior in muffler acoustics, can you comment on when the wave dispersion becomes critical and needs to be taken care? Okay. So, Jaya Salman, are you able to? Okay, fine. You can't hear me, but you can't directly, talk to me. So, it's you instead of saying, it's true that in the course largely have dealt with plane wave only, but rather than talking about dispersion, what is a wave? Dispersion is a phenomenon when different frequency components travel at different speeds. But in acoustics, you have relation between the wave number k and sound speed and frequency as k is equal to omega by c. What it means that all frequencies travel at the same same phase speed. Okay, so acoustic waves are non-dispersive. That is one thing. So, and it's true that, and another thing that I want to quickly mention on this note is that whenever you have a line duct, then of course, then you need to find out the dispersion relation. I mean, it's basically a transcendental equation involving some trigonometric terms or some other Bessel functions or something like that, depending on the geometry. And then you need to solve numerically the dispersion relationship. So here, but I think what you're talking about, wave dispersion, here it is not the wave dispersion that is important. It's a conceptually wrong thing that you're talking about. Wave, it's not the wave dispersion that is causing problem. It's the high order modes, no, or non-planar wave modes beyond a certain frequency, beyond the cut-on frequency that are causing all sorts of problems. So basically what happens is that, as we can see, like for the circular cylindrical duct, you can see that the first cut-on frequency starts at k naught r naught. R naught, let capital R naught be the radius. K naught r naught is equal to 1.84 or something. Okay. So you can figure out what f is correspond to a given sound speed. So beyond that frequency, that 1-0 mode will start propagating. Like this, you can evaluate numerically the other higher order modes. So the point is that it becomes critical. It's not the wave dispersion that becomes critical. It is the onset or cut on of the higher order modes that is very important, and that completely deteriorates the muffler performance. Beyond a certain frequency. So it's so we need to use the correct term. So for a circular cylindrical duct, k naught r naught is equal to 1.84. Is the frequency at which the first higher order mode will propagate, but whether that mode will be excited or not depends on the orientation or the configuration of the inlet and outlet ports. For a concentric chamber, both ports are concentric, then we have the sources. If the ports are located concentric, then only the axis symmetric modes will propagate, and the radial mode 0, 1, 0, 2, 0, 3, only those modes propagate. So the first cut-on frequencies k naught r naught is equal to 3.83. So you can figure out f, and beyond that frequency it will propagate. So main thing is that the main thing is that for concentric configurations, only symmetric modes will propagate, as also is the case for elliptical chamber, even modes. And so the point is, you need to figure out the cut-on frequency. For example, perforated ducts. Again, you need to find out the frequency of the higher order modes, first higher order mode. So that is the frequency at which the plane wave is not quite valid. So you need to consider additional higher order terms apart from the plane wave term. Is that clear? You can say yes or no. Because plane wave is no longer valid, so the predictions cannot be taken very seriously based on the planar wave. You need to consider higher order modes using some sort of a mode matching that I talked about in the 12th week, and or maybe the piston driven model and so on. So I hope I'm clear on these things. So can I get your comments? Okay. So any more questions? Archana Kale, would you please give some MATLAB programs for ready reference, as I'm not at all used to MATLAB and getting confused with TL expressions. So Archana, thanks for your question. Are you a registered candidate for the exam? Will you be writing the exam on the 18th MATLAB based program or on the 24th? Are you, Archana, will you be writing the MATLAB based exam on the 18th or the MCQs? Okay. So I will share with you because the exam is on the 18th, and you have to wait till the 18th because those are like people are going to take exams. So I would suggest that you please wait until the 18th or possibly the 20th, and you can send me your email ID. So you're doing a PhD from where? Your PhD, you're doing a PhD from which university? Is it from India or elsewhere? Outside? Pune University. Okay. So is muffler acoustics your topic? And look, to answer your questions, I'll send you some of these codes you write to me with through the discussion forum, and I'll send you and write to me at my email ID. Or emimani at iitk.ac.in. You write to me at either of these, and I will respond. I'll provide you some simple expansion chamber muffler programs. You can use that or extend inlet and outlet based on the planar wave. I can get you. Yeah, I will. I can send you after the 18th a sample program. So, how did you like the course, Archana? Was it all right? Did you have any issues? Anvesh Kumar. Okay, so Anvesh, thanks a lot for joining, and I see you are also registered for the exam. So, given the automotive mufflers have small dimension and the plane wave propagation is sufficient, how good is the assumption for larger ducts? Example dimension 1500 mm by 200. So, that's a very good question. So, you're talking about the rectangular ducts, right? Yes or no? And I think you're talking about a HVAC duct system, if I can understand correctly. Heating, ventilation, air conditioning, rectangular ducts. But anyhow, the answer is that thanks a lot, Archana, for your comments. Anvesh, your answer to your question is that look, it's generally plane waves are valid only up to the cut-on frequency, like I have been insisting. But given the fact that most of the engine noise happens at the first firing frequency and its first few harmonics, it's pretty okay for the commercial mufflers used in automobiles that we use plane wave only. However, if you have a large muffler, like an industrial muffler application, like I can share a photograph of such a muffler in the in my in my recently published book. So that is basically, just bear with me for a minute, and I will share with you. Um, I'll share with you. So let hang on. So you should be able to watch uh, this thing. Okay, you should be able to watch this photograph. Are you able to watch this photograph? Okay, so this is a elliptical, large elliptical muffler used for industrial operations like excavation and all that. So in such a situation, unfortunately, plane waves are not quite valid even at very low frequencies, because of the fact that evanescent modes they are quite dominant even in the low frequency. Maybe for a limited frequency range you can perhaps use plane wave, but basically, what I'm going to say is that for such large dimensions, this dimension can be like 1 meter uh, major axis, or 800 mm, 900 mm major axis, 350, 400 mm minor axis. For such a thing, you may not have that much. You may not have that much. It's necessary to go to 3D analysis and work on the and basically consider the full three-dimensional field. So I hope that answers the question. Like, that is a numerical mode matching thing. So what we do is that we just like we found out the analytical modes. We figure out the numerical. Figure out the numerical modes. You know modes across the transverse cross section of the elliptical chamber, and match and enforce continuity of pressure and velocity conditions, and then set up system of equations which give you modal coefficients, and we try to solve for them. So basically, that's what we do. Okay. And so that these are all advanced topics which will be covered in the next course, on NPTEL course on numerical and experimental techniques in muffler acoustics. That's what I've tentatively named it. So we will figure out that, we will do something like a numerical mode matching approach, or analytical in some cases, extension of what I've just talked about in the last lecture. And we will figure out that for such large geometries, planar waves will fail, and it's a given thing. So you need to consider really high order modes. So for anyhow, to wrap up this question, for larger ducts with a much larger dimensions, we need to consider the full three-dimensional effect. And that's how I was gradually building up the complexity. Does it answer your question, Anvesh? Anvesh, does it answer the question? So yeah, so I will cover all these things in the later class. I mean, basically, I'll teach how to incorporate, how to do the analytical, sorry, how to find out the eigen modes using finite element technique. Okay. So what are you doing, Anvesh? Are you studying somewhere or are you working in the industry? Oh, it was. I'm still developing the content, so it will take some time. The advanced course. So I'll propose something, and we'll possibly next to next semester. I'll probably need some time to prepare. So, so I just got your mail. So I'm just trying to read it out. So you are. Please send me the matter. I'm just thinking. I have cut. So you have cut means what? I have cut the mufflers of Royal Enfield Classic 350 and Thunderbird. Can you? So what do you mean by cut? Oh, even there could be high order waves inside large mufflers and an impedance tube. Waves measurement as long as they're only plane waves. I didn't understand the question. Even there could be high order waves inside large muffler. Even there could be high order waves inside large muffler and impedance tube. Waves TL measurement as long as the waves. I did not understand the question. Do you mean to say, Jay Selvam, that uh, there'll be high order modes in the inlet and outlet pipes, which are difficult to be measured experimentally? Is it? I did not answer. I did not understand your question, Jaya Selvam. The used ones, Archana, you said. So these are. You mean to say you want to open up the muffler? You already opened up, and based on the complicated things you want to develop or find out the transmission loss. You can do that once you break it up into a number of elements, and you can apply the constituent things and used mufflers are gasket. And now I'm studying the. Okay, very nice. So, is your PhD topic on mufflers, and whom are you working for your PhD in mufflers? You're working with someone for your PhD? I think you're trying to do some reverse engineering. That's good. You're trying to figure out, open up the muffler and try to understand what are the constituents, educate yourself in terms of, uh, yeah, that'll be good. So basically, that is also one of the research agendas in my mind, that you take up some any commercial muffler used in a two-wheeler or a four-wheeler and open it up and try to develop transmission loss programs or attenuation programs for such complicated things. So you'll see a lot of three-pass mufflers too. You'll also have this conical concentric tube resonators which are used in your Harley Davidson motorcycles and all that. So for that you will require a code for CCTL. Dr. Farhar Survey. Okay. So does he work in acoustics? Is it? Does he work in acoustics? Is it? Yeah, but okay, I see. I see. Okay. So, what do you? So, what I did not understand the question, Jaya Selvan. Can you please tell me that again? Explain that to me again. I think you're probably talking about higher modes present in the impedance tube, so the inlet and outlet port. So under such a case, if you have inlet and outlet tubes uh, um, in the inlet and outlet pipes, and possibly it will limit the measurement ability until that point. So you cannot possibly you know measure beyond the plane wave limit experimentally. I'm not sure whether I've answered your question because that's what I could understand. Hmm. Okay. Okay. That, yeah, JS album. That is a better thing. What Murli is suggesting. Anyhow, even though there could be higher order modes inside large muffler, say in an impedance tube based TL measurement, as long as there are only waves in the inlet outlet pipe, even though there could be high order plane waves inside the large muffler, okay. Say in an now suddenly you say in an impedance tube based TL measurement, as long as there are only waves in the inlet outlet pipe, often small in diameter to have plane waves, the measurement would be still adequate. Okay, so I okay, so what I think it's not properly framed question. The English seems to be a little distinct. But I can just make some sense of what you're trying to say. I think you're trying to say that the inlet and outlet pipes in the of the muffler, if they are connected to the impedance tube of nearly the same diameter, and they have only planar waves because the diameter are small, the cut-on frequency is large. But the inside there are so many higher order modes. So will that be okay? Yes, as long yeah in the proper muffler proper in the muffler cavity there could be any number of modes, not an issue. But as long as there are only planar waves that propagate in the inlet and outlet pipes, it should be perfectly fine to measure the. I mean, your measurement will be okay. Not a problem. Have I answered your question, Jay Selvam? But impedance tube measurements and all those things will hopefully be covered in the next semester, next advanced course. So anything else you guys have to ask me? If not, I'll take up the question. Um, uh, what one of the participants have asked. So he asked, Markand Mehta, do you have any prescribed methods to measure insertion loss of mufflers using impedance tube? Will it be worthwhile and able to provide reliable data? So, to answer this question, hopefully this will be transmitted. Um, Look, first of all, insertion loss. What is insertion loss? It's the difference of the acoustic power radiated without the muffler to that radiated with the muffler on. So you don't really need to have an impedance tube if you want to just get the experimental insertion loss curve, meaning that you take out the muffler and let the engine, make whatever noise it is, and measure the noise at a certain location. And then you put the muffler on, and then you measure it again, the noise, and look at the log of the difference, 20 times log of the absolute value. Okay, so you will get the insertion loss. And other than that, if you want to predict the insertion loss using if you want to create the insertion loss using some analytical modeling, you would require an impedance tube measurement, and you would develop certain model, plane wave model, or a high order wave model, including mode matching effects and all that. The point I'm trying to make is that well, we would he would determine the four pull parameters, and then using a number of techniques will determine the source characteristics, that is the source impedance and the acoustic pressure radiated by the source. Once we have that information, then we can analytically or numerically predict the transmission loss. So that would require an impedance tube setup. So yes, it is possible to do that thing, but to get into the details of that, we have to go to another course, because experimental things that is not really have covered in this thing. So so this will definitely provide reliable data, and can we predict transmission loss of a muffler using statistical analysis method? I am not a person from statistical energy method, so I can't really answer this question because I have never worked in SEA. So have I answered all the questions? If you do not have any more questions, I guess we'll probably hang up. So what do you suggest, Murli?
Sir, JSLN posted just now a query, sir.
Okay, I have seen several perforated mufflers with porosity higher than 35%, acoustically transparent. What do you think would be a reasoning behind that, other than a better fluid dynamic design? So the reasoning is that to make it acoustically transparent. This, as you correctly pointed out. So basically, your extended inlet and outlet mufflers, they're counterpart of your concentric tube resonators. And especially if you have a very high porosity like 35%, as you correctly said, they'll behave almost like extended inlet and outlet thing. And in such a case, the performance can be very well compared with the ETR, extended tube resonators. So the real advantage is that the porosity this thing will allow the flow to the guide the flow. So mechanically, it will be like guiding the flow. The flow will not separate, but at the same time, it will allow the waves to interact with the annular cavity. So that is about it. And other thing also, people, something that are not quite covered really in the course, have not done justice, is dissipative mufflers, which will also be taken up in the next course. So you, in the annular area, you completely fill it up with absorptive materials, sound absorbing material, and that really enhances the absorptivity on the attenuation performance, especially at higher frequencies or if you have a muffler of a large length. So basically, what happens is that if you have a highly porous material filled in the annular cavity, and if you have a high porosity, that will allow the waves to interact even in a greater sense more effectively with the annular material and get absorbed. So what is the point in having a very low porosity and a very good, very like 10%, 5% porosity in a very good absorptive material? It doesn't really serve the purpose. So that you'd rather have a very high absorptivity material, and the annular cavity can be filled with this thing. So that is another reason that you have high porosity. That it's just that to guide the flow, the the pipe is just there to guide the flow, the perforated pipe, but the job is just like, it's actually, at the end of the day, it's just transparent. So I hope I've answered this question, Jaya Selvan. Okay, so are there any better questions? Sorry, are there any more questions? I'm sorry, I was reading your thing, better fluid. Are there any more questions? It is nothing like optimize the porosity. You play around is generally, depending on the application, you can play around the porosity and get the desired transmission loss curve. Suppose if you want a peak at a certain frequency and not such a good performance at other frequency, so you can play around with the codes to simulate what the performance would be, and then fabricate the performance and see how are we going about it. So you have to play around and do some sort of iterations. So someone JCQZH, who is that person? JCQZXH. Yes, trial and error. Figure out what at a certain frequency, what do you want? Okay, if you guys do not have any questions, uh, we'll probably end it today. And there'll be another session on the 14th. The timings will be announced by the NPTEL team, so you guys can attend on the 14th as well.
Hi, sir.
Yeah.
Can I stop the broadcast now?
I stopped the broadcast, is it? Or do you?
No, I will be stopping the broadcast, sir. YouTube broadcast.
Yeah. So because there are no questions that is being asked. So
Right, sir. Fine,
okay.
sir.
Okay, then
Stop.
I'll leave the meeting then.
Okay, sir. Okay, sir. Thank you so much for your valuable time, sir.
Okay.
Bye, sir. Thank you, sir.